are measured in degrees. Right? So you saw an angle and it was 50 degrees, or it was 200 degrees, or it was some thing like that, right? Degrees. Angles can also be measured in another unit called radians. And the radian is actually the unit of measure for all math from here on. Now, we'll still do some in degrees because we're like the transition period, but in calculus, everything's in radians. After that, everything's in radians. So the first thing we need to be able to do, just like you did in chemistry, you need to be able to change from one unit to the other. So think about in chemistry, you had so many inches and you changed that into centimeters. Remember that? Or you had ounces and you changed it into milliliters or something like that. We're going to do exactly the same thing. So these are all done all the same way. It's very, very simple. It says take 100 degrees and change it into radians. So we're going to change this into radians. There, as always, more than one way to do it, but here's the way that will never let you down. Pi radians is 180 degrees. So pi radians is 180 degrees. The same way that 12 inches is 1 foot, pi radians 180 degrees. So if you set up this proportion, pi over 180, that's 1. That ratio there, that's 1. Because pi radians is the same as 180 degrees. So then over here, I'm going to say x radians is 100 degrees. Right, now look at that and make sure that makes sense to you. Pi radians is 180 degrees. That'll never change. You're going to use that every time. In this problem, we want to know how many radians are 100 degrees. Does it make sense to you that the 100 is on the bottom where the 180 is? Because these are the degree measures, right? They got to be in the same spot in the graph. So we're always going to have pi over 180. And then over here, we're going to have whatever is in our problem. In this case, it's 100 degrees. Now, we're going to cross multiply. So 180x, just cross multiply, equals 100 pi. So divided by 180, and x equals, now we have to reduce that fraction. I think you can do that without a calculator. We can cancel the zeros out, right? What do I do with 10 over 18? 10 over 18 reduces to 5 over 9, yep. Don't forget the pi is still there, so 5 pi over 9. So the answer to the question is 5 pi over 9. So once again, how many radians is 100 degrees? Well, I set up my proportion, cross multiplied, it's 5 pi over 9. Easy. Next one, negative 60 degrees. Set it up exactly the same way. So what's the fraction that we always start with? Pi over 180. Now you're going to have an x and you're going to have a negative 60. What goes where? X goes on top. Negative 60 goes on the bottom. Remember, this is pi radians, 180 degrees. This is negative 60 degrees, so it has to be on the bottom with the 180. Okay, so I'll cross multiply. 180x equals negative 60 pi. Don't worry about the negative. Angles can be negative. We'll talk more about that later. So x equals negative 60 pi divided by 180. Does that make sense to everybody? Now we reduce our fraction. Always reduce. So again, got the zeros, they'll cross off. Now you've got negative 6 over 18. One-third. So x equals negative pi over 3. You can put a 1 there if you want. 6 over 18 is 1/3. So if you want to make that 1 pi over 3, that's fine. Keep the negative. And the last one, 210 degrees. All right, try this one on your own. What's the setup going to be for 210 degrees? Pi over 180 equals x over 210. Is that okay with everybody? All right, go ahead and cross multiply and see if you can reduce your fraction. Over 18. Out. 3 will go into both of those. So what is it? 7 pi over 6. Is that right? Okay. So what did we just do? We just did 3 examples of changing a degree measure into a radian. All right, everybody got that? Okay, next, going the other way. We have radian measures, and we're going to change them into degrees. Now, this one can be done exactly the same way. There's also an easier way. I'm going to show you that too, but I don't want to confuse you. Start out with pi over 180. Now we need to use this number, and we need an x. So am I going to put the pi over 4 over x, or am I going to put the x over pi over 4? What do you think? This is a radian, and we're changing it into a degree. So where will we put the x? Guys, this is pi radians, and this is 180 degrees, right? This is pi over 4 radians. So is that number going to go on the top or the bottom? That's going to go on the top. So pi over 4 over x. Now I don't want you to get worried about it. I know you probably are, fractions inside of fractions. But I don't want you to worry about it. Go ahead and cross multiply. So pi times x equals 180 times pi over 4. So pi times x equals 180 pi over 4. Remember when we multiply straight across, so 180 pi over 4. Ooh, there's no zeros to cancel this time. But does 4 go into 180? So pi x equals 45 pi. What do you think I'm going to do now? Divide by pi, so x equals 45 degrees. Now kids, I know first day back, all these ugly numbers, pies, everything else. This is easy stuff. I want you to think about this for a second. In the very beginning, one of the first things I told you was that pi radians is 180 degrees, right? That is fact forever. Every problem you ever do, pi radians is 180 degrees. Does it make sense to you that if a whole pi is 180, that a fourth of a pi would be 180 divided by 4, which is 45? So you don't have to go through all this arithmetic if you don't want to. Pi is 180, so whatever fraction you have, in this case it was pi over 4, will be 180 over 4. So if we look at the next one, it's 2 pi over 3. Well, remember, pi is 180. What's 2 pi going to be then? What will 2 pi's be? 360. And what will a third of that be then? 120. So you can always do these problems. If they have a pi in it, you can always go back to that beginning relationship. Pi is 180. I think that's a little easier. Let's do negative pi over 6. Remember, pi is 180. Period. So what would negative pi be? Negative 180. And what would happen if we divided that by 6? What would we get? 180 divided by 6.
Negative 30.
Negative 30. Remember, pi is 180. So a sixth of pi is a sixth of 180, which is 30. All right, try 7 pi over 6. See if you can figure that one out. Either kind of using the shortcut way here or going back and using your proportion. There's a lot more arithmetic with the proportion, but it will always work. See if you can figure out how many degrees 7 pi over 6 is. Shout it out if you think you know.
Is it 30 or negative 30?
No. Now there's a 30 involved here. Look, Scout. We know that pi is 180. Now, what happens if we divide that by 6? What's 180 divided by 6? 30. But, Scout, we have 7 times that. We have 7 of those. So what's 7 30s?
I don't know.
You can calculate. 210 degrees. Did anybody get 210? Good job. Good job. So, I don't know if you were paying attention as I was walking Scout through. One way to do that is to say, okay, I know what pi is. Pi is 180. A sixth of that is 30. And 7 of those is 7 30s, which is 210. Perfect. Now, E, you cannot do that. What is E missing? Doesn't have a pi. And if it doesn't have a pi, you can't do the whole pi equals 180 thing. There's no pi in there. So what we do is set up our proportion, and it looks like this. Now, we know, we've done this a few times now, pi is the same as 180. Why did I put the 2 on the top? Why did I put 2 over x instead of x over 2? Well, this is pi radians, and this is 180 degrees, right? What's the 2? Is the 2 a degree or a radian? Look at the problem. What are you doing? Well, you're changing it into a degree. It says change the following radian measures into degrees. So this is a radian measure. Does it make sense to you that it's on the top then? So now I'll cross multiply. Pi x equals 360. You can use a calculator if you need to. You probably ought to know 180 times 2 is 360. Now remember, you're solving for x. So you're going to divide by pi. And there is the answer to the question. I know it looks funky. We just have to get used to it. All right, and F is a no-brainer. How many degrees is pi radians? 180. Yeah, pi is 180, we know that. So we're all set here. Okay. This, wait, there's one more. There we go. All right. Now we're going to get our calculators out. Hopefully you all brought your calculators. You gotta have a calculator every single day. We can't do most of the stuff we do without a calculator. So make sure you've got it. Okay, I want you to think about something for a minute. If I measured the floor here, and I said that it was 16.5 feet, what would be another way that I could say that, besides as a decimal, 16.5, what would be another way I could say that? Josh?
Inches.
Or Jacob?
Multiply it by 12 inches.
So it would be 16 feet and
6 inches.
8 inches. Oh no, 6 inches. 16 feet and 6 inches, because a foot is 12 inches. So a half a foot would be 6 inches, right? When they measure me, they say I'm 5'6". Well, another way of saying that would be 5.5, right? But they never say that. They always say 5 feet, 6 inches. Okay. Now we're going to do the same thing with our angles. This is a decimal. We need to change this decimal into smaller units, just like feet can be broken down into inches. Degrees can be broken down into things called minutes and seconds. So it's kind of like an hour on a clock. If you think of a degree as being an hour, it has 60 minutes. A degree can be broken down into 60 minutes, and a minute can be broken down into 60 seconds. Now, back when I was taking this class, we had to do all this by hand, and it was torturous. You guys can do it on your calculator. All right, so here's what I want you to do. First thing I want you to do is press mode. Where my finger's pointing, mode, and make sure that, for me it's the third row down, but make sure degree is highlighted, because we're working in degrees. So go down to that row, click over to degree, press enter, and now we're in degrees. The calculator's in degrees. Okay? All right, now, I want want you to type 100.4. Just type the number 100.4. And then go into, okay, for me, it's got purple writing on it. It's called apps. See that button right there? It says apps. Right above it, you see how it's written angle right above it? So we're gonna second apps. That's our angle menu. And I want you to click down to the DMS. That is degrees, minutes, seconds. And press enter. And then press enter again. So the calculator just changed 100.4 into 100 degrees, 24 minutes, and 0 seconds. This is called a decimal degree. It's a decimal, degrees. And you just broke it down into minutes and seconds using your DMS, degrees, minutes, seconds button. All right, let's try the next one. Type in 18.375, just type the decimal. Then second apps or second angle. Click down to DMS. And what did you get for that one? 18 degrees.
22, 30.
18 degrees and
22 minutes.
22 minutes and 30 seconds. All right, one more. Don't let the negative bother you. The negative doesn't, you just type it in. It doesn't make it any difference at all. So negative 20.42. And remember, when we type negative, we use our negative button. Second angle, DMS. Did you get negative 20 degrees, 25 minutes, and 12 seconds? How easy is that? A lot of arithmetic. All right, now take a look at number 4. Number 4, we're doing exactly the same thing, but backwards. Notice that the angle is 132 degrees and 11 minutes. So it has been given to you, as degrees and minutes already. And you want to change it back into a decimal. All right, so here's how we do this. Type in the 132, just the 132. Okay, now go back in the same place you were before, second apps, second angle, and you notice the very first thing in that list is a degree mark. So go ahead and press it. So now your calculator looks like 132 degrees. All right, now type the 11. Go back into second angle and look right under the degree. What do you see right under the degree? The minute mark. So go ahead and press that one. And your decimal is 132.183. I'm gonna have to round it off. Would you agree? Now, pay attention with the next one. This is one of those fluky, crazy things. I have no idea, truly I don't know why it's this way. I'm sure there's a reason. But here we go. Now, we're starting with degrees, minutes, seconds. All right, so go ahead and type in your degrees. 18 second angle degree, and then 12 second angle minute. So does everybody have this on your screen now? 18 degrees, 12 minutes? Okay, now here comes the tricky part. Go ahead and press 13. And I don't know if you noticed or not, but in that angle menu where you got the degrees and the minutes, there wasn't a seconds mark. Wasn't there. Because you know where it is? It is above your plus sign. Do you see it above your plus sign? So you need to alpha plus to get that mark. Second gives you the blue things, you need a green thing. So you're gonna alpha plus. And then press enter. 18.204, is that what you got? If I round it off. All right, try that last one on your own. See if you can remember all the buttons you need to press. To change this guy into decimal degrees, into just a regular decimal. Hayden, I see you writing. What'd you get? Negative 152 point?
311.
311. How does that look to everybody? Good deal. Good deal. All right, we have one more thing, one more problem to do today. Pick up here tomorrow. All right. Find the missing variable for the following. So you got a picture that looks like this. We need to talk about, that's an S. That's an S, not a 5. This symbol right here is the Greek letter theta. And it's just your variable. So it's like an X. In trigonometry, we designate our thetas, our angles, with Greek letters. Alpha, beta, theta, or whatever. So that's just your variable. That represents your angle. R, of course, stands for the radius. And S, again, it's one of those crazy things about math, who knows, stands for arc length. So this is your arc right here that's created by that angle theta. Now for the first problem, we are told that our angle is 2, our radius is 10, and we are going to find our arc length. Formula. Write this down. Put a circle around it. Arc length equals radius times radians. Okay? So for this problem, arc length equals the radius times the radian measure of the angle, so the answer is simply 20. Now, one more comment. If the angle does not have a degree mark, it's automatically radian. So this is a radian measure because it doesn't have a degree mark. We'll talk about what to do if it has a degree mark. All right, welcome back, folks. Please be studying that purple sheet.